Hello everyone, it is Mrs. Griswold here. Today we are on chapter 9A, day 3, and we're going to learn about graphing quadratics. And this is going to look a little bit different than what we did last year, just kind of modifying to what Delta Math has available. But we should know either how to graph quadratic equations in all three forms, or kind of how to take those graphs and write equations. So we're really just going to be relating graphs to the different forms that we have. Okay, so I do have a note sheet for this. Your teacher probably does too. If you want to check Google Classroom, have that printed out in front of you so that you are ready to go. All right, so the first example on the top is graphing in standard form. Okay, so we've got example 1, y equals 3x squared plus 12x minus c. Now on Delta Math, you'll see f of x. I think we talked about function notation before, but f of x and y are basically the same thing. So don't get confused if you see that. All right? So in order to graph in standard form, we have to think about some of the things that we know. Okay, some of this is going to be a little new, but I think we can pick it up pretty quickly. So the first step when graphing in standard form is to calculate and plot the axis of symmetry. Now the axis of symmetry is going to be really important for graphing in standard form. All of our points are going to kind of revolve around the axis of symmetry. If you remember from the first day of notes, the axis of symmetry is calculated by negative b over 2a, right? That's if we have the equation in standard form, right? And we want to find the axis of symmetry. On our homework in the past, we just looked at the graph and figured out what the axis of symmetry is. Today, we're going to actually have to use algebra to calculate that. Okay? So I want to take my a and my b value from my equation and calculate that. So negative, whenever I substitute in a number, I like to substitute it in parentheses. That way, if it has a negative or something, I can always, I don't forget that. So my b in this case is 12. So negative 12 over 2 times a is 3. Okay, so you should be writing all this work down on your note sheet. When I simplify that a little bit, I get negative 12 over 6. And then I do want to do that, simplify it further. Negative 12 divided by 6, that's going to give me negative 2. Okay? So that gets me the equation, the axis of symmetry that you want to write underneath that spot is x equals negative 2. Instead of looking at the graph, we've calculated it using our formula. And now I want to plot that. So I find where x is negative 2. And remember, this is a vertical line. So it's going to be up and down on your on your note sheet. If you want to sketch this in a vertical line at x equals 2. We like to do a dashed line because it's not technically part of my graph, but it is an important part that's going to help me graph the rest. Okay, so first step is to calculate and plot the axis of symmetry. Now, step 2 is going to be to find the vertex. Now, we haven't done this before. We're using a lot of algebra. We're probably not used to using a lot of algebra. But I know that the axis of symmetry hits the vertex. But I don't know where along this whole line does the axis of symmetry hit the vertex. So what I have to do is I have to plug in the x value of the axis of symmetry and calculate the y value of the vertex. Okay, so it's a little tricky. Remember from the last slide, we got x equals negative 2. I'm going to plug negative 2 in to my original equation for x and solve for y. So I've got y equals 3. Now when I substitute in, again, I like to put parentheses because it does make a difference, times negative 2 squared plus 12 times negative 2 minus 5. Okay? Now continue on evaluating. You can use your calculators, of course, if you need to. This is going to be 3 times 4 minus 24, because that's 12 times negative 2, minus 5. Okay, and when you evaluate that in your calculator, let's see, 12 minus 24 minus 5, we get y equals negative 17. Okay, so we did all that algebra. Now we need to take the x, and I need to take the y, and I want to put those together to create my vertex point. So negative 2, negative 17. Then plot it on my graph. So that point is going to be right there. Okay, now I kind of know a little bit more about where my graph is going to be. I also know that it's going to be concave up because of my A value, but I need to be more precise. I can't just plot my vertex and then just throw some points down. I have to pick specific points. So the next step, step 3, is to find the y-intercept and plot it on my graph. Remember, the y-intercept comes from the C value. So we talked about this yesterday. Y-intercept is 0, negative 5. So I can plot that point 0, negative 5 on my graph. But because the axis of symmetry cuts my graph perfectly in half, I can get another point just by reflecting it. So if this is the axis of symmetry, this point is 2 points that way. I can get the other half by going 2 points that way. Because the axis of symmetry cuts the graph perfectly in half, it's like a mirror reflection. So we'll say reflect over the axis of symmetry and then write what that point is. So that point is negative 4, negative 5. Okay, so on Delta Math, we need at least 5 points to get a good picture. So you'll see on the next part, we are going to, whoops, I still have this up from before. We're going to use a table, and whenever we check our answers on Delta Math, they will have a table for us, and the values should be very similar. Okay, so the first value I'm going to rewrite some of the points I already have. Okay, so the first point I'm going to list is my vertex, which I already have. My vertex is right here, and that's at negative 2 for my x, negative 17 for my y. So that's one that I already know. Okay, then I already have my y-intercept. If you're not labeling vertex and y-intercept, you should, because it's going to really help when you get to the homework. Okay, my y-intercept was at 0, negative 5. Okay, then the other point I got was the reflection of that. So I'm just going to abbreviate reflection, R-E-F-L. And that's that other blue dot we have up there, which is negative 4, negative 5. Okay, we need 2 more points now. So this is where the rest of the instructions on step 4 is important. It says pick an x value and plug it into the equation to get the y value. So next to this one, I'm going to say choose. So this one now I get to pick. Okay, I want to pick either on the left or on the right of my vertex. I could pick any number, really. But to make sure my point isn't like way off my graph, let's just pick x equals negative 1. Okay, so I'm just choosing that. I'm going to plug it in, and then I'm going to see what I get out. So when I choose to plug in negative 1, now this is why there's so much space here, because I need to plug negative 1 in to figure out what that y value is. So I've got 3 times negative 1 squared plus 12 times negative 1 minus 5. So at this point, you want to be like, well, where did negative 1 come from? I pick that. You choose what x value, okay, just to get another point on my graph. Now I chose -1, I want to evaluate it. 3 times -1 squared, -1 squared is going to be +1, so that's going to be 3. 12 times -1 is -12 minus 5. And then when you plug all of that in, you get -14. So now that's a point on my graph. I plugged in -1 as my x, and I got out -14. So that is now a new point. But I need 5 points. Instead of doing more algebra, I can do what I did with the y-intercept. I can reflect it across the axis of symmetry. We'll do that. So if this point is 1 over there, then this point is going to be 1 that way. Because it's symmetrical, it's going to be the same distance away from that axis of symmetry. And then I would like you just to write that reflected point. What did we get? We got -3, -14. Okay, now we can sketch. So remember to make it nice and round. We don't want any pointy parabolas. Those are called absolute value functions. And then we've got our parabola. So it is a lot of work, but normally we would have to make tables and plug all this stuff in for each form. But we are just doing standard form. So it's really important that you follow each step and you really understand what we're doing. Okay? Let's do another example. So this is the next one on your sheet. On the top of the back side, I got y equals x squared minus 4x minus 5. Come on. There we go. These graphs are a little weird. Okay. So on our worksheet, I have a little bit of the steps, but I also want us to think through it a little bit because on the homework, Delta Math doesn't say, step 1, find the axis of symmetry, right? We have to know what to do when we're just given a blank equation and a graph, okay? So step 1, axis of symmetry. Okay, remember, -b over 2a. I've got a, b, and c. Okay, when I plug these values in, -b, my b value is -4. So it's -4. That's why I substitute with parentheses, because it makes a difference when I have a negative. A value is 1. Okay, so -4 is going to become +4, all over 2 times 1, which is 2. 4 divided by 2 is 2. Okay, so this is my axis of symmetry. Now I can plot that. Remember, it's a vertical line, and we'll do it dashed because it's not technically really a part of our graph. On Delta Math, you actually cannot plot this. It just wants you to plot points, but you have to find that in order to find the vertex anyways, so it's important to have. All right. Step 1 is axis of symmetry. Step 2 is vertex. So I'm going to take x equals 2, and I'm going to substitute it in. 2 squared, y equals -4 times 2 minus 5. Okay? 4 minus 8 minus 5. And we get y equals -9. Okay, so my vertex, let's see, where should I write it? I'll write it over here, is the point 2, -9. This would be the first point that you plot on Delta Math. So 2, -9, that's my vertex right there. Okay, next, step 3. Is to find my y-intercept. That comes from my c value, 0, -5. Hey, it's the same as the last one. Plot, and then reflect. reflected across the axis of symmetry. Okay, I kind of like that I can drag that dot, so I'm going to keep doing that. Remember, it's 2 points that way, so to reflect it, I have to go 2 points that way. And now I get my reflection. That is at 4, -5. All right, and I've got all of that there. Okay, last part is to make a table. I'm going to make my table a little bit differently. Actually, no, I won't. Let's make it over here. You have a table on your notes, but I don't have one in here. Okay, so our x value, remember we start with the vertex. Let's call it the vert. Remember for that we got 2, -9. Then I got my y int. Okay, for that we got 0, -5. Then I reflect that. And then I got 4, -5. I have 3 points. Now I need to get another one. So this is step 4. Pick an x value. Okay. So remember, I write choose because this is dealer's choice. What x value do I want? Oh no. There we go. All right, well, look at what I've got so far. I could plug in 1 and see where that lands. Right? I can plug x = 1 and see where that lands. So let's choose 1. And then we're plugging it back into our original equation to figure out that y value. So this is where we're going to show our work. So I've got 1 squared -4 times 1 -5. So it's going to be 1 -4 -5, and that gets us a value of -8. Okay, so that was the dealer's choice. When I plugged in +1, I got -8. Okay, now I'm almost done. I just need one more. I can just reflect it. So from the axis of symmetry, if that one is 1 to the left, then the reflection is going to be 1 to the right. I can sketch my parabola. Luckily, Delta Math will actually make it for you. But that reflection point is 3, -8. Okay, it's important that you're showing all of your work for these tables, and I believe we will have a handout on the homework for 4 questions where you have to show this work so that we make sure that you've got it down. Okay, that is standard form. Next on your note sheet, you can say graphing in factored form, in parentheses, writing equations from graphs. We aren't going to be given factored form and then have to graph it. Delta Math doesn't have that, but what they do have is given a graph, write the equation. Okay, so step 1 is going to be identify the x-intercepts or the zeros or the roots. Right? Remember, all 3 of those words mean the same thing. So in that space between step 1 and step 2, I want you to write these. Right? It crosses right here and right there. The first point is 0, 0. And the second point is 5, 0. Okay, those are the zeros or the x-intercepts. And then step 2 is to put in the equation. Okay, in that space next to factored form, I want you to write the factored form equation. Okay, if you don't remember, it's right here. And again, assume a = 1 for now. So we kind of just like put a 1 there, and we don't have to deal with it yet. But you will in advanced algebra. I know because I'm doing that on Thursday with my kids. Okay, so I've got 2 points. I know I'm going to have 2 parentheses. I've got an M. Let's just say this first point is M, and I've got an N. Okay, I'm just going to take those and put them into the equation. So the equation is x minus M. Well, my M is 0, so x minus 0. Then the other half of the equation is x minus N. which is 5. Okay. The last step is to think, well, x minus 0 is just x. So what you will probably see on delta math is x times x minus 5. Okay, remember, the sign in the formula and the sign of the point are opposite. So the point is positive 5. In the equation, it's negative 5. You should have practiced with that before. These ones are going to be multiple choice, so it should be pretty quick to find the equation that matches. So let's try another one. Okay, what if it looks like this? Okay, graphing in factored form. Which equation choice would represent the graph shown below? Step 1, identify the zeros. Well, remember on the first day we talked about how there could be 0, 1, or 2. Well, in this case, there is only 1 at 3. Okay. When I put into the equation, we have to have 2 x's, or it's not x squared. So what you'll see in delta math, remember pretend a is 1, you'll see x minus 3 times x minus 3. It repeats, okay? Or it's x minus 3 squared. You've seen that before, okay? That 0 repeats. So there's like 2 of them. I know there's only 1 on there. It's the same value, but if we don't have 2 x's, then we don't have x squared, and it's not a quadratic. So if this is confusing, then maybe write yourself a little note somewhere on your note sheet. If the vertex, or if there's only 1 point, then it repeats. Okay? This one, I want you to look at it, and I want you to look. This is exactly what delta math is going to look like. You'll have 4 equations, and you have to select the right one. So pause this video, try this problem, and then once you think you've got the one that is right, then you can press play. Okay? So step 1 is to find the zeros. I'm just going to write them down. So one of them is negative 2, 0, and the other one is negative 1, 0. Okay? Then when we put it into the equation, remember factored form, we're going to have 1, is x minus m times x minus n. So let's say this is m and this is n. X minus negative 2 and x minus negative 1. What happens to those? It becomes x plus 2 and x plus 1. Okay? So we know it's not that one because it's that negative. We know it's neither of these because you don't have an extra x. And then we see that this one matches exactly what we have. So you'll see some questions like that on there as well. Okay, so we did standard. This is factored. You don't have to graph, but you do have to be able to look at a graph and write the equation. Lastly, you can think of is graphing in vertex form. Okay, so the first step of this is going to be taking the equation and finding the vertex. So this is exactly what it will look like on delta math. Remember, vertex form, x minus h squared plus k, and the vertex is hk. So when I find the vertex of this one, it's at 4, 3. Remember, it's opposite of h, same as k. Okay, and then you're going to drag the green dot, fill in on your work template or your note sheet, the green dot, and then you flip upside down with the blue dot. Okay, so I can't really maneuver this without being on delta math, so I'm going to pull up delta math and show you exactly what I mean. Okay, so here is a problem. It says graph the equation shown by transforming the given graph of the parent. So I find the vertex, okay, opposite of h, so it's going to be positive 4 for my x, same as k, so positive 3 for my y. Notice how I'm dragging the green dot. I'm not doing anything with those blue dots. I just drag it over and up. Now it's at my vertex 4, 3. Okay? And then that other step on your homework, it says, flip upside down if A is negative. Remember, A is the concavity. So if this is negative, that means it's concave down. But the graph that I have right now is concave up. So what you want to do is you want to grab either of these two blue dots. You can pick whichever one. I would say don't do those because it might mess up your graph when you flip it. Okay? If this is up 1, to flip it, I just bring it until it's down 1. Notice how it moved all those other points with the graph. And then just be careful not to stretch it. So it was originally up here. I don't want to like move this dot way over here. I don't want to move this dot way over there. Okay, I want to keep it 1 over and 1 down. Okay, so that is how you will graph in vertex form. Okay, so I just wanted to show you something like that. It's not too bad, just really dragging that vertex and then flipping if you need to. All right, that is all that I have today. You can go ahead and start working on that homework.